Hello, my name is Loren Sunding, and this video is meant to provide a brief overview about my senior project. The topic of my project is researching the application of gearbox drivetrains for commuting bicycles. Today's bicycle commuter faces many challenges. Sharing the road with motorized vehicles can be a very dangerous environment, and bicycle commuters must be sure that their equipment is in proper working condition. A major problem with current chain and derailleur drivetrains is reliability and maintenance intervals. Derailleur devices are very fragile and exposed on the external of the bicycle frame. Any small impact can negatively affect the shifting performance of a commuting bicycle because of the fragile nature of external drivetrains. The purpose of this project is to study a potential solution to this problem. If produced cost effectively, a gearbox drivetrain could be a solution. Pictured on the left is a traditional derailleur drivetrain. Shifters mounted to the handlebars or frame pull cables which actuate the derailleurs and in turn change the driving gear. On the right is another bicycle drivetrain option, the internally geared hub. Rings of planetary gears provide different ratios. Both of these options function very well, but derailleurs are fragile and require constant adjustment, while internally geared hubs are prone to failure from heavy load. A gearbox designed for a bicycle would provide the following advantages. It would be fully protected from external elements such as water and dust. There would be a longer service interval, meaning there's less time adjusting and replacing worn components. It's a more robust design that is less prone to damage from crashes or accidents. And finally, it provides a lower center of gravity in a central location, leading to a more stable and predictable handling bicycle. Some of the design constraints for the prototype gearbox include 2 gear ratios, a handlebar mounted shifter, maximum input of 300 pounds onto the cranks, maximum width of 4.5 inches for ergonomic pedal spacing, a 52mm chain line to accommodate standard rear wheels, a material cost of approximately $500, and the design must be manufacturable with Poly equipment. This is a SolidWorks rendering of my proposed design. Riders will stand on pedals attached to the crank arms here and apply force. This force will be transmitted into the input shaft, which is directly geared here to the middle shaft. The middle shaft has 2 gears on it that have different ratios, and it also has a dog-tooth style shifting mechanism. This shifting mechanism is pulled back and forth by a cable attached to the shifter on the handlebar. Depending on which gear is selected, that gear will then power the output shaft here, which will have a cog attached to it that runs a chain to the rear wheel, powering the bike. Nearly all of the machine components were manufactured in the Advanced Manufacturing Lab in the IME Department. The housing, covers, and crank arms were machined using the Haas VF2 CNC mill. The shafts and shifting assembly components were machined using the Haas ST10 CNC lathe, including the live tooling, and the Haas TL1 lathe. The gears were machined using the VF2 mill and keyed using a push broach. Currently, 90% of components for the gearbox are complete. After a test assembly to check fit, the steel housing will be welded to a bike frame and tested in the field for 100 miles. This is a simple cost breakdown for the prototype gearbox. Assuming a standard shop rate of $60 an hour, the prototype costs $1,765 to manufacture. This is an estimate of cost per unit to manufacture a batch of 25 units. About $500 could be saved when increasing quantity, and assuming about 20% less machining time will be needed due to more efficient tool paths. Assuming the gearbox will be manufactured in the United States, it will cost $2,410 for manufacturing and other related costs, such as marketing, sales, and engineering. Currently, the largest company to offer domestically produced bikes utilizing a gearbox is Co-Motion Cycles in Oregon. They offer a complete bike with a German gearbox for $6,365. If Co-Motion made a frame with the prototype gearbox, it would cost $5,875. A few things to note are that the German gearbox has more available gear ratios and runs in a fully sealed oil bath, so inherently it provides more value to the customer. I believe that if testing goes well, it will be worth pursuing this gearbox idea. Future iterations need to be lighter and more cost-effective to manufacture. Continued work on developing gearboxes for bicycles will surely lead to better riding experiences for commuters. Thanks for taking the time to watch my senior project video.